question. Is it clear? Who has this? Orpit Anand. This is clear? What you have to do? I don't know. So basically, always directional derivative means that you find the gradient along a particular direction. So that is also called projection. Like if you have a vector, let's say this is along x coordinate, this is y coordinate, and this is any vector A. And if we told you to find projection of A along, let's say, x direction, so that will be A dot I cap. So dot products gives you the direct, whatever we call this projection of a vector along that particular direction. That is basically dot product or directional derivative also. Tutorial 2 का solution कैसे करें सर? Which question? You have to tell this. Tutorial 2 का solution समझ नहीं आ रहा. Which one?
एग्जैक्टली सर शुरू कहाँ से करो वही समझ में नहीं आ रहा.
Which question?
सर कोई भी क्वेश्चन सर, एक आध दो हुआ सर, बाकी सर नहीं हुआ.
That's why we have this tutorial section. That's why you have to tell which question. Let's start with question 1. Question 1 is simple. We told you to convert this rectangular coordinate to cylindrical spherical coordinate. How we will convert this one? We gave you this coordinate -1, 1, √6. This is in Cartesian coordinate. So how we will get the cylindrical spherical coordinate in this case? Who has solved this?
सिलेंड्रिकल सर, सिलेंड्रिकल में तो x बराबर होता है रो साइन थीटा और y बराबर रो कॉस थीटा. वैसे करेंगे इसको.
Yes.
Sir, we discussed the formula for rho 2 previously.
So you have to find it the other way around. You have to find that. Okay. So let's say let's try to convert this in cylindrical. Let's do it quickly in cylindrical system. So cylindrical or you want spherical? Let's do spherical. That is easier. I want to do the easy one. You guys do the hard one. This is let's do in spherical coordinate. So in spherical, so we have to find out r, theta, and phi, right? So r is basically what? R is basically x square plus y square plus z square, right? Like if in Cartesian the coordinates are x, y, z, and in spherical this is r, theta, phi, then you can say r is basically √x square plus y square plus z square. So then this will be √(-1 square plus 1 square plus √6 square. Well, then whatever be the value, that is the value of r. Okay. And what will be the value of theta in terms of x and y? Can you guys tell what will be the value of theta? What is the value of phi in this case? Can you guys tell me? What is the value of phi? Theta and phi, how to find theta and phi? We have this relation, so you guys should be able to find out. These values are x equal to r cos theta sin phi, y equal to r sin theta sin phi, and z equal to r cos theta. So I gave you the value of this relation of x, y, and z in terms of r theta phi. You guys should be able to reverse this.
यस सर हो जाएगा. सर यहाँ सर जो z वाला कोऑर्डिनेट है यहाँ सर थीटा फाई निकाल लेंगे.
Yes. So I told you value of r. So okay, you can then find out what will be the value of cos phi. Then you can find out what is phi and theta. Okay, so this way you have to convert. Similarly, you know the relation in cylindrical coordinate. If you reverse the relations, then you will get the coordinate from there. So question 1 and 2 is basically this finding out these coordinates in this different coordinate system. Question 3, I just told you to describe the surface, how the surfaces looks like. Question 4 is same. Question 3 was in cylindrical coordinate system. Question 4 is now in spherical surface. I'll give you only one example. Question 4D, I told you to draw this one. R equal to sine theta sine phi. Sine theta sine phi. This is in spherical coordinate system. Can you guys find out what the surface will look like? This surface? Anyone? How this surface will look like? So what we can do, we can say R equal to sine theta sine phi. So this will be, if you multiply R both sides, this will be R sine theta sine phi, right? And R sine theta sine phi, that is basically Y. Y equal to R sine theta sine phi. And R square is basically X square plus Y square plus Z square equal to Y. So you can say X square plus Y square minus Y plus Z square equal to 0. Or you can also say X square plus Y minus half square plus Z square equal to 1 by 4. Can you guys tell me now what the surface is?
Fair.
Yes, this will be again a sphere, but this is not centered at x equal to 0, y equal to 0, z equal to 0. This sphere is
Answer
linked.
0, 1 by 2, 0.
Yes. Okay, so these are the solution of like this. Question 5 I already told you. Question 5 I discussed or not? Yes,
I
question 5
heard
I
about
already told
the
you.
tutorial 1.
Tutorial on which question?
Question number 11.
Question number 11. What is tutorial 1? Grad square 1 by R0. What is the problem here? This is
Sir,
you.
if I solve this, I get 3 upon x square plus y square plus z square for 3 by 2.
This is what this we told you, right? This grad square 1 by R equal to 0. And grad square is basically del 2 del x2 plus del 2 del y2 plus del 2 del z2. You have to do the simple derivative in this case.
I did not write it like that, gradient dot gradient.
You can do this. Okay, this is called Laplacian operator. Okay, this is called Laplacian operator. So I don't know whether I mentioned this or not. This is called Laplacian. Yes, yes.
Then why did it not write like a gradient into dot gradient 1
This
by
is
r?
basically gradient or gradient.
Yes, sir. If we solve this question by this method, sir, we get another answer.
Okay, this is this should not be 0, right? Even if you do
Yes,
this
sir.
one,
Here, sir, this answer comes 3 by r cube.
if you take this Laplacian operator, then also it is not 0, right? Yes, I think it is not 0. You should get value like this one, minus 1 by r cube. No, this is you should get this value minus r by r cube. Most probably this is the value you are getting, right?
No, sir.
No?
I get, sir, 3 by r cube.
3 by r cube.
No, sir, 3r by r cube.
3r by r. Yes, it will 0 at least. Okay. Okay, my pen value. Yes, let me check. This may not be 0. Let me check quickly. This should not be 0. Most likely this is not 0. Let me check quickly. This is grad square 1 by r. This is not gradient. Yes. This is probably a mistake. This should not be. Let's do it quickly. Better. What let's see what this value is coming. Grad square 1 by r, right? So this should be del 2 del x2 plus del 2 del y2 plus del 2 del z2, and here it will be 1 by root over x square plus y square plus z square. So this is the derivative we have to do, right? So okay, let's first do this term, this del 2 del x2 of this one. Let's do this one. So first let's find out del x of 1 by root over x square plus y square plus z square. What will be this derivative? This will be minus
Minus 1 by minus x upon y same.
x square plus y square plus z square, right? No, to the power 3 by 2. This is the answer, right? Del x.
Yes, sir.
So what will be del 2 del x2? Del 2 del x2. This will be. So first let's do this part. This part will be 3x. You will get 3x, and this is so you will get 3x square, x square plus y square plus z square to the power minus 5 by 2 minus x square plus y square plus z square to the power minus 3 by 2. This will be the derivative, right? Del 2 del x2 of this function. You will get this. This one correct or not? Can you guys confirm quickly? This is I think this is correct. So what we'll get here? So if we keep this one here, x square plus y square plus z square 5 by 2. So here we'll get 3x square minus x square. So we'll get 2x square minus y square minus z square. This will be the answer, right, for del 2 del x2 term? Similarly, you should get del 2 del y2, it will be similar. So you have just x will be changed by y. So this will be 2y square minus x square minus z square divided by x square plus y square plus z square to the power 5 by 2 and del 2 del z2, this should be 2z square minus x square minus y square divided by x square plus y square plus z square to the power 5/2. So if we add all this term, then grad square 1 by s, 1 by r, what will be this? So this will be x square plus y square plus z square to the power 5/2. So we have 2x square, x square, x square. This is 0. This should be 0. Is it correct or did we did some mistake somewhere? I think this
Sir,
is
I
correct.
think second derivative went wrong.
Second derivative is wrong. Which one is wrong?
Here u by v will come now.
Why? So why this is wrong? So first we did this. We kept x constant, and we did differentiation for this one. So differentiation, this should be n x to the power n minus 1. So minus 5/2, and then we this is 3/2, and this is x squared 2x. This is correct. This is not wrong. Anyone else can you confirm what will be the value? Is this correct or not?
Yes, sir, this is correct. I got 0.
I think this is correct. Okay, we can Wi-Fi. See. I think this is 0. This is 0. This and this question is correct. Okay, let me find my iPad. Any other question?
Sir, tutorial 2, question number 6.
Tutorial 2, question number 6. Verify divergence theorem. Who has been able to solve this one? What is the divergence theorem? Can you tell quickly? What is the divergence theorem? What you have to do in this case? Okay. So question 6. This is tute 2, question 6. So we told you to verify divergence theorem. So divergence theorem is basically you connect volume integral with closed surface integral, right? So here we gave you a vector. We gave you this vector a equal to 4x I cap minus 2y j cap plus z square k cap. And we told you to do verify divergence theorem for a cylinder. We told you that this is the cylindrical surface for which the equation is x square plus y square equal to 4 and is bounded between z equal to 0 and 4, right? Okay, so divergence theorem. So this is basically divergence of A dV. This should be equal to A dot n cap ds. This you have to verify, right? Over this box, this cylindrical box. So when you do this volume integral, that means the volume of this cylinder, and when you do the surface integral, that means you have to consider these three surfaces. That you have to consider this upper surface, you have to consider this bottom surface, and you also have to consider this circular surface, this curved surface. This lower surface is given by z equal to 4. Upper surface is for lower surface. This surface, let's say this is surface S1. This surface is z equal to 0. Let's say this upper surface is S2, which is for which z is equal to 4. Oh, not 4, 3. I told you 3. Z equal to 3. And for the curved surface, let's say this is S3. For this case, x square plus y square, this is equal to 4. Who was able to solve this one? Or all of you have the same problem? Anyone? How you can do the volume integral? Can you guys tell how you can do the volume integral here? So volume integral, I told you this is divergence of A dV. What is the volume element dV in this case? What? So if you have the volume integral in Cartesian coordinate, let's say this is a cube. Okay, if you want to find this volume, how you find the volume? What is the volume for this cube? Let's say this is x, this is y, and this is the z direction. What is the volume for this cube? Simple cube, tell me please.
dx dy dz.
Yes. So this is dx, dy, dz. Simply volume means what? You have to take the dot product of all, because these are orthogonal coordinate system. Okay. So in Cartesian coordinate system, your volume element is always dx, dy, and dz. Okay. So you replace dv simply by dx, dy, and dz. And this part you can do. What will be the value of divergence of A in this case? Can you quickly tell what will be the value of divergence of A? Divergence of this quantity will be how much? It will be del x of 4x, right? So 4 minus del y of 2y. So that will be 2 plus 2z. So this will be 4 minus 2. This is basically 2. So this is 2 plus 2z dx, dy, dz. And for dx, dy, dz, what will be the limit now? So that is the important point. How to find the limit in this case, okay? So for z, I already told you, z goes from z equal to 0 to z equal to 3. So the limit will be for this z equal to 0 to 3 for the z. And for the y is given by x square plus y square equal to 4. So y lower limit is y equal to minus root over 4 minus x square. Upper limit is root over 4 minus x square. 4 minus x square. And x limit will be minus 2 to plus 2. So how to do this volume integral is that first you do the integration for z. And for that, during that time, you consider x and y is constant. So let's write this little bit clearly. So this is the volume integral. You are going from 0 to 3 minus root over 4 minus x square to root over 4 minus x square and minus 2 to plus 2. And our equation is 2 plus 2z dx, dy, dz. Okay. Now, when we do this z integral, we'll consider x and y is constant. Okay, so dx, dy will be constant. Then can you do this integration, this 2 plus 2z and dz? for this given limit 0 to 3. Can you guys do then? What will be this integration? 2 plus 2z, let's say this is constant. Forget about this dx and dy.
15.
0 to 3, simply you can consider 2 plus 2z dz. You can find out what is the value of this integration. It will be some constant, right? And that will come outside the integral. And then you will leave with only this in part, minus 2 plus 2 minus root over 4 minus x square to 4 minus x square dx dy. So now you consider dx is constant. You do integration only for dy over this limit. Okay. And then once you get that value, you then finally do the integration for x. You will do this step by step. Okay. I think you guys should be able to do this integration now. Okay. And the second part is that you have to verify this for this surface a dot n cap ds. You have to show this volume integral is equal to a dot n cap ds. So as I told you, this is a cylinder. Okay. So in this case, you have three surfaces. So for this lower surface, this surface 1, what will be the n cap ds? What is the direction of n cap? For surface S1, this is x, this is y, and this is z. For this bottom surface, what is the value of n cap? What is the surface normal? In this n cap is the surface normal, right? N cap is the unit normal to the surface. So what is n cap for the surface S1, this bottom surface?
Z.
Yes. What is the value n cap in this case? You don't have to be right. You can tell
minus k.
Minus k.
K.
It is directed towards minus z axis, right? So this should be minus k cap. So you know the n cap. So here, and what will be the surface element in this for this sphere, this circle? What will be ds? This we know minus k cap. We have to find ds also. This is on the xy plane, right? This S1. S1 is on xy plane. So what will be the expression for ds? ds will be dx into dy, right? ds is basically a small surface area on that particular plane. So this cylinder is sitting on this xy plane. So what will be the surface element for this particular bottom surface? It will be dx dy. For this upper surface, this S2, which is given by z equal to 3, what will be the value of n cap? For this surface, if n cap is along this direction, right?
K plus.
So this will be plus k cap. And what will be the surface element?
Same, sir.
It will be also same. dx into dy. So you know this vector A, and if you know n cap, then can you do this integration? If A is given, what is the value expression for A? We gave you 4x I cap minus 2y j cap plus z square k cap. So then A dot k cap, this will be basically z square, right? So you have to do this basically in this integration z square dx dy for both z equal to 0 and z equal to 3. You have to do twice for the two surface. And finally, you have to do this surface also. X square plus y square equal to 4. X square plus y square equal to 4. For this also you have to find the surface normal. So how we will find the surface normal for this surface, this curved surface? You have to do again a dot n cap ds. You have to find the surface normal. How will find the surface normal in this case? N cap for this curved surface. So can you remember some operator which gives surface normal? What we have taught you so far? Gradient, right? Gradient basically gives you surface normal. So this is basically phi equal to x square plus y square equal to 4. This is a surface. So if you take grad phi divided by mod of grad phi, that will give you surface normal, right? That will give you n cap. So in this, for this surface, this integration will be a dot n cap you found, and ds in this case will be dx dz by mod of n cap dot j cap. Okay. When you have a curved surface, then you have to take the projection of the surface element on a particular plane. So in this case, if this is x, y, and z coordinate, and if you are taking a surface element here on the curved surface, so you have to take the projection of that on a particular plane. If you take on xz plane, then you will have this expression dx dz by n cap dot j cap, and then you have to evaluate this integration. You guys try whatever I told you so far. You guys try, and if you guys still have problem, then you tell me again in the next tutorial. Okay. Can you guys try from this point or not to solve this one? Yes or no? Okay, so if not, I don't know. Let's stop it here today, and then if you guys still have question, then we can discuss in next tutorial. Okay. We will meet again tomorrow. Let's end it here. Okay. We'll meet tomorrow.